Do subscribe to eKida channel and press bell icon to get updates about latest engineering, HSC and IIT-JEE main and advanced videos.
Hello students, next question is question number 16 of JEE Mains 2015 physics paper discussion. So in this session we'll discuss about question number 15. Students, let us start the question number 16. The question number 16 says that in the given circuit, the circuit is a capacitor, three capacitors are there. The charge Q2 on 2 microfarad, the charge on this 2 microfarad capacitor changes as C varies from 1 microfarad to 3 microfarad. So the value of C, this is variable given and it is varying from 1 to 3 microfarad. So Q2 as a function of C, because as this will change, the charge on this also will change. Okay, now then it says that Q2 as a function of C is given properly by which of the following case? That means we are plotting the graph of the charge on 2 microfarad capacitor and the capacitance of the C capacitor when it changes from 1 to 3 microfarad. So in y-axis we have taken the charge on Q2 charge, and x-axis the C. As the C varies from 1 to 3, you can see 1 to 3, 1 to 3, 1 to 3. How the charge will change in the 2 microfarad capacitor? Starting with some value, it will go to other value. So all these cases there is variations, but we have to see which variation is correct one, whether it will vary linearly or like this or that. So we have to check the equation. So first of all, let us find the value of Q2. So if I use the circuit, let us draw the circuit first. The circuit is, this is question number 16. The circuit is, here is C and that varies from 1 to 3, and I have a capacitor over here which is 1 microfarad here and 2 microfarad here, and there is a battery which is connected over here, E. The charge on this is Q2, which will change as C changes, C increases. Then what will happen to Q2, that we will understand first. Let us find the charge. If this is C, suppose the capacitance is C, then what is the charge on this? Let us find that first. If I have to find the charge on this, I have to find how much charge is actually flowing through this. They are parallel, so charge will be distributed, but what is the actual charge coming in? So I have to find the net charge in the circuit. In series the charges will be same, so whatever charge comes in, that will flow through this and also through this combination, and that will be division of charges over here. So if I find the equivalent capacitance of these two capacitors, C1 and 2 are in parallel, so the equivalent of this is, then it is 1 plus 2, that is 3. In parallel, the equivalent capacitance is 3 microfarad. So this can be thought of as one capacitor here and one capacitor here and a battery over there. This is E, the battery potential, this is C, and this is 3 microfarad. This is in farad, microfarad obviously. So now 3 microfarad. Now I will if I look for the equivalent of this C and 3, then for this circuit C equivalent will be, they are in series, so I'll apply product 3C divided by 3 plus C. This is the net capacitance of the circuit. So we know that the charge is CV, the C equivalent into V. Here it is 3C by 3 plus C into E is the voltage over here. Now, after you have put all those values, I come to this conclusion that the charge that is flowing from here is Q, which I supposed, and I got the value as 3CE divided by 3 plus C. This is the charge which is flowing over there. Out of this whole charge that is flowing here, this part, the whole charge is accumulated here and accumulated here as well. But this is the combination of 1 microfarad and 2 microfarad capacitors in parallel. So there will be division of charge as the charge here is 3 times this. Suppose the charge here is Q, which is Q here. Here also it will be plus Q minus Q. This is plus Q. This is minus Q. And here the Q charge is traveling is divided into 2 different parts. What will be the charge on the capacitors? Because they are in parallel, the capacitors are in parallel, so therefore the potential is same. In this equation, any equation of QCV, if V is constant for these two, then the charge depends upon the charge is proportional to the capacitance. More the capacitance, more the charge. Here it is 2 times. So here the charge will be 2 times than here. So out of this total 3 parts of the charge, 3 parts of these, 2 parts will be here and 1 part will be here. So in this one, the charge that will flow here is CE upon 3 plus C, and in this we have 2CE upon 3 plus C. So therefore, finally we got that the charge on 2 microfarad capacitor is, this is the charge, this is the case. Now if I rearrange this, then I'll get 2E divided by I divide that by C to Q to E, then I divide by C, then I have got 3 by C plus 1. This is the case. Now I will write it again. The charge is 2E divided by 1 plus 3 divided by C. But the C, depending on the C, because the C varies from 1 to 3 microfarad. So if I put 1, and if I check for the concavity test, for if I go for the concavity test, that as I gradually changes the capacitance from 1 to 3 microfarad, the capacity, the charge on this second 2 microfarad capacitor, that will change. Whether it increase, decrease, that we'll see. Now you see that if I increase, I put the value of this as 1, I get 2E by 4. If I put this, I am getting. If I put suppose 2, this I am getting, because this is 2.5, 5 by 2, so 4 by 5, 4 by 5 E. So from here, this is actually 0.5 E, and here, if I multiply 2, this is 0.8 E. That means the charge is increasing. As the charge is increasing, if I put C equals to 3 here, you can check it. If you put C3 here, then I am getting 2E divided by 3 here, 3 cancels, 1, 2, so it is 2, it becomes E, that is 1E. So basically what happens is that as I change the value of C from 1 to 3, the charge on this starting from 0.5 times the battery voltage to 1 times. So initially whatever it is at 1, at 3 microfarad capacitor, it will become double. So that means it is increasing. But by nature we know that the charging of capacitor is, we have seen the manner in which the charge is stored in a capacitor. It is whether the charging of capacitor or discharging of capacitor. We have seen that the charging of capacitor follows this curve. This is how charging of capacitor follows. It follows this type of curve. Starting from, if I go for a capacitor without any charge at the beginning, and there is a resistor connected over here, and I'll connect a battery of voltage V, the capacitance C, the resistance R. By the time I close the switch at time t equals to 0, when there is no charge, so gradually the charge initially is 0, and finally after time infinite the capacitor is fully charged, and that grows exponentially, and that equation can be often as charging of capacitor is charge at any instant of time is the final charge that has to be stored is the maximum charge, which is obviously the CV, and this capacitance and the battery voltage, and e raised to minus t divided by the time constant. If I put t equals to 0, that means this is 1 upon e raised to 0, 1 upon, this becomes what? This is 1 by, this is 0, 1 by e raised to 0 is 1, 1. So this becomes 1, and this is discharging, and the charging of capacitor is 1 minus Q maximum 1 minus e raised to minus t by tau. So in this expression, this is nothing but e raised to minus t by tau, which is 1 by e raised to t by tau. If I put t equals to 0, then it is 1 upon e raised to 0, which is 1. This is 1, this is 1. 1 minus 1, 0. Initially it is 0. So this is the equation we are going to use for charging of capacitor. So initially obviously it was 0, so this is the equation that we're going to use for the charging of capacitor. Whether this one discharging or this one charging, this function is there, exponential function. So obviously, as we will see here, that is increasing, and this is this nature is like that. Therefore the charge will be convex, the curve will be convex. So this is not the answer, this is not true, this is not linear, this is not decreasing, this actually the charge is increasing, so this is the correct answer. It is convex in nature. So therefore, like this, the charge will increase like that. This part is correct. This will gradually increase. So, and I can say that the charge here is the E by 2, and here the charge will be equal to E. During this time, from here to here, this will be like that we have discussed so far. So that is the answer to this question. Okay, so the correct option is 2. That is the answer. Thank you.